So, Amit, file infector viruses are what we call the classic
That's
form
right.
of virus, right? We know all about them. They operate in memory. They usually infect executable files with the intent to cause permanent damage, or make them unusable, which is permanent damage, really. And most of them operate in a DOS 16-bit environment.
That's right.
Now, a file infector virus either overwrites code or inserts infected code into the executable file. Right. So when an infected file is executed on a system, the infection routine will seek out other files, right? Try to spread, insert its code into them, generally at the beginning. Yeah, absolutely. Generally at the beginning or at the end of the existing file of prepending or appending viruses when we're talking about those. But also occasionally in the middle of a file with what we call a mid-infector.
Mid-infector.
Yeah, or by spreading itself across gaps in the file structure. Now, it's interesting. The entry point of the file is redirected to the start of the virus code to ensure that it is run when the file is actually executed, and control may or may not be passed on to the original program in turn.
Now, file infector viruses often do not perform the intended process by either leaving the file completely non-functional or simply failing to run the viral code at all.
That's right.
More sophisticated forms of the infector viruses, which really try to hide their presence by changing aspects of their code with each infection, are known to, as a polymorphic or metamorphic virus.
Right.
So this type of virus can infect a number of operating systems, including Apple, Mac, Windows, and the Unix operating systems.
All right, let's talk about boot sector viruses. As you know, they're mostly the same as file infector viruses, but we use a different name as an indication of a virus developed for newer OSs. A boot sector virus is a computer virus that infects the master boot record, or MBR. And this kind of virus was started a long time ago, even maybe before you were around, with MS-DOS and floppy disks. Guys my age, we know it. The virus used to depend on an infected floppy disk forgotten in the computer, but now even non-bootable media can trigger the spread of boot sector viruses.
Right.
Now, these viruses copy their infected code either to the floppy disk's boot sector or to the hard disk's partition table. During startup, what happens usually is the virus gets loaded to the computer's memory, and as soon as that virus is saved to the memory, it then immediately infects the non-infected disks used by the system. Hence, viruses spreading.
That's right.
All over the place. And when infected non-bootable disk, we call it a VBR, or a volume boot record.
Now, whatever is stored in the first sector of a bootable storage floppy diskette, USB device, hard disk, etc., is not required to immediately load any bootstrap code for an OS. The BIOS merely passes control to whatever exists there, right? So as long as the sector meets the very simple qualification of having the boot record signature of 0 by 55 or 0 by triple AA in its last 2 bytes, this is why it's easier to replace the usual bootstrap code found in an MBR with more complex loaders. Even large multifunctional boot managers or programs stored elsewhere on the device, which can run with an operating system, allows users a number of choices in what occurs next.
That's right.
So for a malware working from the OS or application side to be able to infect that boot sector, then it must have a low-level programming, or it would have a hard time propagating to that area, infecting other areas. So, however, since NT-Loader is readily accessible from Explorer or MS-DOS, really all you have to do is have the right access to the system file.
That's exactly right. Yeah, and to combat this virus's behavior, the BIOS often includes an option to prevent software from writing to the first sector of any attached hard drive.
That's right.
Just a safety measure. And it could thereby protect the master boot record, which contains that partition table, from being overwritten accidentally, but at the same time, not the volume boot records in the bootable partitions. Now, something I want to bring up here, depending on the BIOS, it attempts to write to the protected sector. It may be blocked with or without user interaction.
That's right.
And, viruses kind of get sneaky that way. And most BIOSes, however, will display a pop-up message giving the user a chance to override the settings. So we do have that capability built in. The BIOS option is disabled by default. And the reason why is because the message may not be displayed correctly in graphics mode, which is the way we look at it, right? So by blocking access to the MBR, this may cause problems with the operating system setup program. programs, disk access, encryption, important thing, partitioning tools, things that may not have been written to be aware of that possibility.
Right.
So, and in that case, it's very easy that it could cause them to abort very ungracefully, as we say, and possibly leave the disk partitioning in a very inconsistent state, which frankly nobody wants.
Nobody wants that. Ghostball was the first multipartite virus discovered in 1989. Now, for a virus to be called a multipartite, it doesn't really need to focus on files and boot sectors. Now, as the name indicates, the virus has a multiple vector attack. Ghostball had the capability to infect program files and boot sectors at the same time. So these viruses can spread faster than normal viruses.
Right, and the multipartite virus keeps infecting, keeps going, infecting all the files on the computer and, of course, the MBR. Antivirus applications will detect the existence of the virus, mostly because you will have a huge amount, really, of infected files on your computer, and it happens very quickly. Now, I didn't say that it will be removed, however. The antivirus detects it, but it could remove the infected files or clean them, but the MBR would still be infected, and by definition, it then will infect other files again and again and again until it's completely extracted. Now, if you try to clean the MBR and you still have one file infected, again, it will spread again and infect the MBR. And you're stuck in that interminable evil loop of destruction.
Not good.
No.
Okay, so the next type of virus we're going to talk about is a macrovirus. But before knowing what a macrovirus is, we're going to need to know what a macro is. Do you know what a macro is?
I do, but I'm going to let you explain it.
Okay. So a macro is a series of commands and actions that help automate tasks in applications like Microsoft Office. That's what you were going to say, right?
Right, yeah. It makes things easier for the user.
The document contains a small application built with macros that runs when it's executed. Macros are mainly used by developers to tailor an application for their needs, or within an application like Word or Excel to allow the user to request sequences of commands easily.
I think I just said that. Makes things easier on the user.
You did
Nicely done. Yeah, but since macro commands are contained in the document itself, if this document spreads or is sent to someone, the virus by definition will piggyback and come with it. So a macro virus is simply a virus written with macro language. That's really it. The danger of this type of virus is its ability to spread quickly. When a macro virus runs, all of the documents on the infected computer become infected too by definition. So some macro viruses may find the contacts book and send an email containing an affected file. Another, at the same time, could delete data from the infected document. Macro viruses can do a lot of damage. They can infect both Windows and Mac computers. The first macro virus is called Concept, way back in July of 1995. The biggest hit, though, was from the Melissa virus, which also included a worm. So double danger there.
Yeah, those were some big ones. Moving on, resident viruses are probably one of the worst kinds. They reside in the memory and can infect any file or application executed depending on their programming code. Now, they're divided into two categories. We have fast infectors, which spread quickly and cause noticeable damage. And then we also have slow infectors, which spread widely as they are slow and are hard to detect. Now, resident viruses don't need an infected application to run in order to replicate themselves. Now, since it's residing in the memory, it's going to activate itself when the system boots up.
Right. Yeah, and the epic damage of this kind of virus is, and you've alluded to it already, is that it can attach itself to antivirus applications and then in turn infect any file opened by the antivirus for a scan. So you think you're doing something good and you're actually making it worse.
Find it and then
right. Yeah, and so non-resident viruses are a contrast of resident viruses. They need to be executed by the user, and they quit the memory when the system reboots or shuts down. After the system reboots, the virus needs to be executed again.
That's right.